Lesson 72, lines from experimental data and negative angles. We'll first of all look at lines from experimental data and then move to the negative angles. On this experimental data that we were given, this plot with all these dots, so the relationship between salt and carbon, we could try to put a line on here that would be the average, or that would catch as many dots as possible and kind of be the middle of the road line. So we could draw a line on here like that. They drew two lines, there'd be two options here. I would probably shoot for the middle of the road actually, and I'd come up through in between here, because I think you're going to be more accurate if you would be in between there. So we need to look at a plot and put our line on. One line on here I like, one line on here I don't like. This is the class practice one. This first line is not very good for several reasons. It starts a little high down here and then ends a little low, a little under. I think it'd be better if it would start about in the center and end about in the center. So that second line, the one that starts here and ends up here above, is the one we want to look at. So we're going to draw, you just draw or imagine a line on, please, if it's in your book with pencil, but put a line on there. And then we need to change that line and find the slope-intercept formula and change it into h equals mc plus b. So we're going to start with y equals mx plus b is what we're looking at. I'm going to change it to h equals mc plus b. Now the first thing we need to do is try to find the slope of this angle. So we notice that we've passed through this point here at 85 and 100 perfectly, and then we cross through this point up here again perfectly. So we have to go rise over run and see what the difference is. Now with the rise, one thing to watch on here is we can't just count squares, because it isn't just squares, it's actual numbers that go further. So from 85 up to 100, we've got a rise in there of 15. So we're going to put 15 on the top. And our run from 100 to 102 is only of 2. So 15 over 2. And 2 goes on the bottom. Now, our ordered pair back here that we worked with 185, we can continue working with those numbers, or we could work with 100 and 102, whichever we like. I'm going to go with 85 and 100. No, I like how this is put. I'm going to go with this one. So I'm going to go with 100 and 102. It shouldn't matter what you go with. And we're going to put 100 in for hydrogen and 102 in for carbon, and solve for B, figure out what our B is. So 100 equals 15 over 2 times 85 plus B. And now I'm going to whip out my calculator and take 85 times 15 divided by 2, or we just take this 15 divided by 2 to find our slope. So 15, I'm going to go 15 divided by 2 equals 7.5. So we've got a 7.5 slope. It's going to be good enough to use a decimal instead of a fraction here like we've done before, times 85 plus b, and 100 equals this. So let's go and solve the 7.5 times 85. Clear 85 times 7.5 equals 637.5. So 637.5 plus b, 100 equals, and now we'll subtract 637.5 from both sides, minus 637.5, and we end up with a negative 537.5 equals b, and that's what our b equals. Now we're ready to change this into this actual formula that they want to see. So we go h equals mc, so 7.5 c, that's our slope, 7.5, and then minus 537.5. That is going to have to be close enough. If you would look at the actual answers in the answer key, you'll find that you're not always exactly the same, and the reason why, of course, is because you drew your own line on here. and it's going to come out a little bit different, but it shouldn't be too far off. I noticed the answer that's given for this one is they've got 8.33 for the slope and negative 753 instead of negative 537. But it's going to be close enough for what we're working with today to work. Okay, so that's that part. Now, the next part is looking at changing polar coordinates into rectangular coordinates, and we're dealing with negative polar coordinates. So I'm going to copy down right here what they give us for class practice A. We've got 5 and then an angle negative 230 degrees. And we need to deal with this 230 and find out what he exactly is. And then in the process, I hope that we can review how to find these polar coordinates. It's not difficult at all. Remember two things, or one thing. Remember cosine and sine. Remember cosine first, and then sine. So cosine and sine. Now, what we're going to do before we get going, because this is the part that I think is often mistaken, is we need to actually draw a little diagram and show these polar coordinates and which way we're going. So when we're dealing with polar coordinates, we always start always over here, and the positives always begin to move in this direction around. Now a negative just means we're moving in the opposite direction. So we start over here and we move in the opposite direction. And this is 90 degrees. This would be 180 degrees, this would be 270 degrees, and then back again at our 360 degrees. So if we're negative 230 degrees, we start over here, we cross over the 90, we cross over the 180, and our point is going to be up in, this is 270, so our point's going to be maybe about in here. So about in there somewhere is where we end. So we came riding around to that point. Now, we need to change this into a degree that is always off the x-axis. So this point is how many degrees from this x-axis? And we could imagine a little triangle going on right here. So how many degrees do we have between 180 and 230? So we go 230 minus 180, and we get 50. So we're dealing actually with a 50-degree angle. So you could write this if you want, 550. Now, time to remember cosine and sine. So, cosine, first of all, we'll look for the cosine of a 50-degree angle times 5. So, cosine of a 50-degree angle times 5. And then we'll look for the sine of a 50-degree angle times 5. And then we'll go to the sine times 5. And that will get us our coordinates with does the right come first or does the up come first? The right always comes first, with the right first. So cosine is the right and sine is the up. So I'm going to punch that into my calculator just so you can see how this is going to work. So we're going to go cosine 50 degree times 5. We're going to go all clear. 50 cosine times 5 equals 3.21 is going to be good enough. So we're going to go 321. 3.21, and that the right always comes first, and then 50 sine times 5, clear, so 50 sine times 5 equals 3.83, so 3.83 up, 3.83 up. Now, right and up. Now, one thing to look at before we go further, and that is, here's our point. This point is up, right? It's up from our x-axis. Is it right from our y-axis? No, it is left, so it is the opposite of right. So we need to put a negative here. Make it negative 3.21 right, and then it's positive 3.83 up. That's all that's to it. It's actually not difficult at all. Make sure you draw this thingy here so that you get the thingy, the point right, and so you can figure out how many degrees this angle is off of this x-axis. If our point would be here, then we'd figure how many degrees are here. If our point would be here, we'd figure how many degrees. No matter where it is, always go to this x-axis and figure how far away it is for your degree. And then just remember cosine over sine. So find the cosine first. Cosine of the 50 times 5. Sine of the 50 times 5. And cosine 50 times 5 gets this number. Sine of 50 times 5 gets this number. Have fun.